Welcome to Sum of Finite Geometric Series. So we talked about in the last video how a series is when you take a sequence, a list of numbers, but you add them all together. And we even went over the formula that will help us do that. This video is just going to focus on that again, but go over way more practice problems. So for the first question we have, what is the sum of a geometric series with 6 terms whose first term is -4 and whose common ratio is 2? Now, they're telling you that this work is incorrect and you have to find the error. Can you spot it? So if you notice, the usual formula is S sub n equals a sub 1 minus a sub 1 times r to the n over 1 minus r. And right here, they have -4 minus +4. So that's two different a sub 1s, right? Because this one is telling you that a sub 1 is equal to -4. So this should really be -4 minus -4. And that's where the error is. So the solution is incorrect because they forgot the negative for the second a sub 1. Now, the solution is incorrect, but what is correct? So we have that the n was correct, that the r value is correct, and it's placed in the right spot. So you can say the solution's incorrect, but the other terms are placed correctly. Now, the solution is incorrect, so let's actually fix it. So the correct answer is s sub 6 is equal to -4 minus -4 times 2 to the 6th over 1 minus 2, and that should really give you -252. Makes a big difference. Now again, we have the formula for the sum of a finite geometric series. Keep in mind that this formula is on your reference sheet, so you don't have to remember it. And let's try a different example with it this time. So they want you to find the sum of a geometric series, and they want you to round your answer to the nearest hundredth. So let's try to find the variables that we need. We have the first term is 40. We have that r is what you're multiplying each term by, which in this case is 1.005, so we know it's increasing by 0.5%. And then you have to find the number of terms. Can you see how many there are? The answer is not 11. So if you notice, this is the first term, right? The second term, the 11th term. If you look right here from, that was terrible. If you look over here, we're going from 1 to 11. So there are 11 terms without including that first one, right? It's really 40 times 1.005 to the 0 power. So in actuality, even though it goes up to an exponent of 11, we really have 12 terms. So n should be 12, and that's the trick in these types of problems. When you go and set everything up, the sum of the first 12 terms is 40 minus 40 times 1.005 to the 12th power over 1 minus 1.005. Put that in the calculator and see what you get. If you get 493.4224949, and if you leave it like that, you'll be wrong because this problem asks you to round to the nearest hundredth. So the actual answer is 493.42. Let's try another one. We have that Alexa earns $33,000 in her first year of teaching and earns a 4% increase in each successive year. They want you to write a geometric series formula for her total earnings over the n years. So because they're talking about the series formula, we're going to use the formula that we had on the top of your page. And you need to figure out what is your first term, what is your ratio, and how many terms are we talking about. Your first term is the $33,000 that she makes her first year. The R is not 0.04, right? Because you're increasing, so you need a 1 plus R, 1 plus 0.04. So R, your common ratio, is 1.04. And we're talking about n years. So we actually don't have what n is. This is just the general formula. So please make sure you use S sub n, especially because they're telling you to use it. We have 33 grand minus 33 grand times R to the n over 1 minus R. And you're done. That's the basic formula. Now, using that formula, you can find how much she earned the first 15 years of teaching. So that's your n value, right? So we're going to plug it in, the sum of her first 15 years to the 15th power. Put that in your calculator and round it to the nearest cent, that is 2 decimal places, the nearest hundredth. And you should be getting that over 15 years, she earned $660,000, $778.39 in total. It's actually not a lot of money for 15 years worth of work. Let's try an actual Regents question for multiple choice. We have that Jake wants to buy a car and hopes to save at least $5,000 for a down payment. And we have that the table below summarizes the amount of money he plans to save each week. So based on the plan, which expression should he use? Now, they're using a series formula because they're adding up how much money you save per week, right? So you have to add everything together to find the total amount saved. Just looking at all of these without looking at the actual numbers, looking at your answers. Some of these already seem off, right? Because if you look at the exponents, some have an exponent of n and others have an exponent of n minus 1. And you should know for this formula, if you look on your reference sheet, you want just an exponent of n. So cross out the ones with the n minus 1s. Now, all you have to do is figure out the first term, and your first term is $2. So go with the one that has the proper first term of $2, and you're done. You don't even have to figure out that the common ratio is 2.5. But if you wanted to, you would do 5 divided by 2, go backwards, is 2.5. go backwards. 12.5 divided by 5 would give you 2.5, and that's where they're getting the common ratio from. Let's try another example. They're giving you the first term of the geometric sequence is 8, and the fourth term is 216. They want you to find the sum of the first 12 terms of the corresponding series. Series means we should be using that formula. Now, we know it's the sum of the first 12 terms. We know that the first term is 8. We don't know the common ratio. So we have to actually figure that out first. In order to find the common ratio, you got to use the first sentence that they gave you, right? They're giving you the first term is 8, and the fourth term is 216. So in order to do this, we're making 3 jumps, and because it's geometric, we are multiplying by r each time. So 8 times r cubed. If you're stuck on this part, just go back to my previous video on finding terms in a missing geometric sequence, and I'll explain how to do this process. When you solve for r and divide by 8 on both sides, you get r cubed is equal to 27. And from there, when you take the cubed root, or if you raise both sides to the 1/3, whichever one you prefer, you should be getting that r is equal to 3. So I'm going to take that and plug it in. Now you're going to put this all in the calculator and see what sum you get. And you should be getting 2125760 to be choice 3. Now I'm going to skip around in the rest of the packet, but please actually continue watching because the problems that I'm going over are the more difficult ones that have little tricks to them. So I do just want to mention this one because I know a lot of us make calculator mistakes. When you want to actually do this, right? A sub 1 is 3. Your r value, first of all, because it's going between positive and negative, you know it's going to be a negative common ratio. That is the only common ratio that will get you to oscillate between the signs. From there, you're actually multiplying by -4, and n is going to be 8, right? The first 8 terms. So when you plug this in, s sub 8 is equal to 3 minus 3 times -4. Please make sure that you actually put parentheses around the negative, because if you're not, that might be where you're going wrong putting this in the calculator. Always put parentheses around negative values. Anyway, if you put that in the calculator, you should be getting choice 3. Now we're going to make a big jump, and we're going to go to question number 10. So we have that Jasmine decides to put $100 in a savings account each month. The account pays a 3% annual interest compounded monthly. They want to know how much money will she save after 1 year. So for this question, we're talking about months, right? But then it mentions that you have a 3% annual interest compounded monthly. So you can't talk about months and annual at the same time. So automatically don't choose the ones that have the 1.03 because that's different rates. Cross those out. I'll show you where they're getting the 1.0025 from. We're talking about compound interest, right? The formula for compound interest is A equals P times 1 plus R over N to the NT. Now, this part in here is really 1 plus our rate is 0.03 for 3%, and your N is going to be 12 because we're compounding monthly, right? And there are 12 months in a year. If you put that in the calculator to find your true growth factor, the true base, you're going to be getting 1.0025. And that's why it's going to be choice 2 or choice 3. Now, the difference between choice 2 and choice 3 is that one is a series, right? So you're finding the sum, and the other one's just an overall amount. So for option choice 2 and option choice 3, you have to figure out which one's right. Now, the wording is super important in this problem. It's saying that you invest $100 each month, not just once. Do you get what I mean? This problem is your basic interest formula, and it's saying that you're starting with $100, not that you're depositing another 100 each and every month. So that can't be right at all. And then you're only left with choice 2. So let's explain where this is actually coming from. So if you're talking about putting $100 in the bank in January, right? You are going to make interest on that 12 times, right? Because there's 12 full months in a year. And then you're going to input another $100 in February. But because that's the second month of the year, you're only going to get interest on it from February to December. So that's 11 months worth of interest. If you go and put $100 in March, you're going to get 10 months worth of interest on it, right? And you're going to keep on going until you get to your interest payment, not payment, until you input another $100 in December. And in December, that's the very last month, so you're only going to get interest on that for the month of December. So only 1 month worth of interest. And when you look it up and you add all of these months worth of interest together, that becomes, it looks like kind of the series formula that we had in one of the first few examples in this video. And that's why it's choice 2 with the series formula. Let's try 2 of the challenge problems at the end of your packet. So for number 12, you have, if the following sum represents a geometric series, then which of the following is the value for the sum? So doesn't look so bad at first, right? We know that we have to use the formula. S sub n equals a sub 1 minus a sub 1 r to the n over 1 minus r. As we go and actually fill things in, I don't know how many terms there are, right? I know that my first term is 5. I know that my common ratio, I can see that I'm multiplying by 3 each time. Don't know how many terms there are, so you have to actually figure that out first. Now, if you think about it with the explicit formula, right? You have the explicit formula for a geometric sequence is this. And the reason why I'm using that is because I know the first term, I know the common ratio, and I know the last term that they gave me. So basically I know my a sub n, I just don't know what n it is. So a sub n is 98,415. My first term is 5, common ratio is 3 to the n minus 1. In order to solve for that, you have to divide by 5 on both sides. And when you do that, you get 19,683 is equal to 3 to the n minus 1. How do you think you solve that, right? We want to solve for an exponent, you have to use logs. So you're going to keep the base and switch the other two values. So log base 3 of 19,683 is equal to n minus 1. You're going to put this in the calculator using alpha window 5, right? Alpha window 5 will get you logs in the calculator. You don't want to hit the log button next to the number 7 on your calculator because that's going to give you log base 10 and you specifically want log base 3. And we're going to get in the calculator 9. Now make sure you don't get a decimal for this because remember we're trying to figure out how many term numbers there are. And you can't have term number 5.5, right? You always want whole numbers when you're talking about the terms of sequences. So if n minus 1 is 9, that means n has to be 10. So I'm going to take that 10 and plug it in. And then when you plug everything into the calculator, you should be getting 147 620, which is choice 2. So keep in mind that geometric sequences and geometric series are modeled by exponential functions. And sometimes to solve exponential functions, you have to use logarithms. Last one we're going to try for the video is number 13. So they want you to figure out the number of terms, n, for the geometric series, kind of like the last one, right? We have s sub n is equal to a sub 1 minus a sub 1 times r to the n over 1 minus r. We have that s sub n is negative 7,812. A sub 1 is negative 2. If I were you, I would put the negatives inside parentheses. Your r value is 5. We do not know what n is. And 1 minus 5. When you start to work this out, first of all, you should simplify the denominator. So we have negative 7,812 equals everything on the right. If you want, you can turn your double negatives into a positive. Over negative 4. Now, to get rid of a denominator, you have to multiply by it on both sides. Make sure you multiply by the negative to get rid of it. When you do this, you should be getting 31,248 is equal to negative 2 plus 2 times 5 to the n. Now, to solve for n, you want to get the base by itself. So you're going to bring the 2 over, right? And you're going to get 31,250 is equal to 2 times 5 to the n. You still need to get the base by itself, and you have to divide by 2 on both sides. That's going to give you 15,625 is equal to 5 to the n power. And to solve for an exponent, you have to take the log. You keep the base and switch the other two values. So log base 5 of 15,625 is equal to n. Plug it in the calculator using alpha window 5, log base, and you should be getting 6. Remember, you're talking about how many terms there are, so we want a whole number as your answer. And you want it to be positive too, because you can't have a negative amount of terms when you're talking about sequences. And that's all for this video. I hope it helped.